Question: ds. Is x over y greater than x over y whole squared? Condition 1. 0 is less than x, which is less than 1. Condition 2. Y is greater than 1. Solution: let us solve this ds question using the variable approach. Let us follow the first step of the variable approach by modifying and rechecking the original condition and the question. We are required to verify whether x over y is greater than x over y whole squared, or whether x over y is greater than x squared over y squared. Square is important in inequality questions. This is an approximately 48 level question. Let us multiply both sides of the inequality by y squared without any effect on the inequality sign, which is squares are important. Then we get x over y times y squared is greater than x squared over y squared times y squared, or x times y is greater than x squared. Thus, we are asked whether x times y minus x squared is greater than 0, or whether x times of whole of y minus x is greater than 0. Follow the second and the third steps. From the original condition, we have two variables, x and y. To match the number of variables with the number of equations, we need two equations. Since conditions 1 and 2 will provide one equation each, C would most likely be the answer. Recall three principles and choose C as the most likely answer. Let's take a look at conditions 1 and 2 together. Condition 1 tells us that 0 is less than x, which is less than 1, and condition 2 tells us that y is greater than 1, or 1 is less than y. This means that 0 is less than x, which is less than 1, which is less than y. So, 0 is less than x, which is less than y, or y is greater than x, which is greater than 0. Thus, x is greater than 0 and y is greater than x, or y minus x is greater than 0, and therefore their product, x times of whole of y minus x, will also be positive. Thus, the answer to the modified question is x times of whole of y minus x whole greater than 0 is a unique yes. So the conditions combined are sufficient according to CMT1, which states that the answer will be in terms of a unique yes or no. Both conditions 1 and 2 together are sufficient. Thus, C is the correct answer. Answer C.